In this video, we will look at Lewis structures. We will determine the Lewis structure for an ion, the Lewis structure for some simple molecules, and determine the Lewis structure for a molecule where the element in the center of the molecule does not follow the octet rule. Let's start by looking at chloride, Cl-. We know that chlorine is in the 7th column and therefore has 7 valence electrons. So we start by saying that we have 7 valence electrons. Now the chloride ion has a negative charge. That's 1 more electron. If we take our 7 valence electrons and our 1 for the negative charge, we have 8 total electrons around the chloride ion. Put the symbol in the middle, Cl. Start by putting the electrons around the Cl one at a time. Now that only gives us 4 electrons. So now we start to pair up. You'll notice that we have 4 pairs around our chloride ion. This gives us an isoelectric effect of a noble gas. This follows the octet rule. Now let's look at the Lewis structure for a simple molecule, methane, CH4. For this one, we're going to have 5 atoms, carbon and 4 hydrogen. Let's start by drawing the symbol for carbon, and let's put the number of valence electrons around carbon. Carbon is in the 4th column of the periodic table, so it has 4 valence electrons. We start by putting 1 electron around the carbon, then 2, 3, and 4 until we have all 4 valence electrons. Notice that we did not pair any of the electrons. We then look at hydrogen. Hydrogen is the 1st column, so it only has 1 valence electron. So we'll put 1 dot, 1 electron, next to the hydrogen. We do this for all 4 hydrogens. To come up with a Lewis structure for this molecule, we're going to have to combine these and come up with bonding pairs. For there to be a chemical bond, we have to share 2 electrons. So we'll start with the carbon in the center. It has the most non-bounded electrons. Then we'll start attaching our hydrogens to these. Notice that now, 1 bond from carbon, 1 bond from hydrogen, we now have a bonded pair. Notice that carbon has 4 hydrogens around it. This is the Lewis structure for methane. Also notice that there are no lone pairs on the hydrogen because each hydrogen only had 1 electron. Our next example, let's look at carbon dioxide. In carbon dioxide, CO2, we have carbon with its 4 valence electrons, just as in methane. Oxygen, in the 6th column of the periodic table, will have 6 valence electrons. Again, draw the first 4 electrons, unpaired. Now electron 5 and electron 6, we're going to have to pair up. This gives us 2 paired sets on our oxygen. These are lone pairs and will not be bonding unless necessary with the other atom. Now we put carbon in the center, again because the carbon has the most unpaired electrons. Put an oxygen on either side of the carbon, and notice we now have 2 bonded pairs. We should check our octet. When we count, we see that carbon only has 6 electrons, and both oxygens only have 7. This is not sufficient for the octet rule. So we're going to move more electrons in. We're going to move an electron from the carbon and 1 electron from the oxygen between the first carbon and oxygen, and do the same with the second oxygen and the carbon. Now notice we have 2 bonded pairs between the carbon and the oxygen. This would be a double bond. So the Lewis structure for carbon dioxide has double bonds between 2 oxygens. When we double check our octet, notice that this Lewis structure has 8 electrons around the carbon and both the oxygens. This is the correct Lewis structure for carbon dioxide. For our last example, let's look at a molecule where the central atom does not necessarily follow the octet rule. A good example of this is aluminum or boron. Both of these can exist with stable molecules with only 6 electrons instead of the normal 8 that follows the octet rule. Another couple of examples of elements where you'll have stable ions or compounds where you do not follow the octet rule is phosphorus and sulfur. Both of these often are hypervalent, meaning that they have more than 8, such as the cases in sulfate. Let's look at a Lewis structure for our aluminum chloride, AlCl3. Here, aluminum being in the third column, only has 3 valence electrons. So draw the 3 electrons around the aluminum, represented by dots. Remember not to pair. And chlorine. We've already shown chlorine with 7 valence electrons. We show those 3 chlorines, and then we start to combine. Notice in this case, we have a chlorine on bonding with each one of the electrons from the aluminum. And on the aluminum, we have an empty spot. We'll find out as we move on through chemistry that this is actually an empty p orbital. But at this point, because we know that aluminum is stable without following the octet rule, we can leave this empty. Lewis structures are very important. We're going to use them over and over again. It's important that you practice with Lewis structures and that you can take a simple chemical formula using Lewis structures, the number of valence electrons, and charges if there are any, and come up with a stable structure. Practice and get confident.